Hi everyone, I'm Utang Neo from Team Fountain. Our interaction design project for the DECO7385 course is called Eco Garden. I truly think it's a really cool idea, using hand gestures to control a fountain and water plants while encouraging collaboration in future work. Let me talk about the challenges we faced, how we solved them, how we iterated based on feedback, and my personal contributions. In the early stage of the project, we planned to create an interactive garden where plants could express themselves through a screen, sound, and vibration. Juan and I started by using materials available in the lab. We programmed servo motors to make the plant leaves shake. As a gesture of thanks after watering, we also used a small pump and coded a musical fountain. This was the prototype we presented in our first presentation. Where I was the presenter, the teaching team gave us feedback that the idea of using a screen on the flower pot was a bit repetitive. The scale was small, and the fountain and the plant didn't feel truly connected. Also, it lacked elements of multi-user interaction. So, we iterated. We replaced the screen with lights, kept the sound and vibration, and planned to let users control the fountain's height and direction with gestures. I was in charge of sourcing and airshipping all the new components: fake flowers, flower pots, a large water pump, a fountain base, and various sensors and electronics. I also handled basic material purchases from ETSG. I arranged the flowers myself for our garden setup, and also took care of exhibition item requests to allow the pump to rotate freely. I 3D printed a custom gimbal mount. I was also responsible for printing all other structural parts. I often stayed late in the lab to solve printing issues like untangling filament jams, which we jokingly called flying kites, and reprinting fragile components that broke easily. After printing an extended servo arm, I mounted it securely inside the flower pot. By our second presentation, our eco garden already looked beautiful, and we added distance sensors to control the fountain's direction. However, we discovered that the large pump couldn't pull water properly from underwater, and the two pumps interfered with each other. So we moved the pump outside the water tank. Later, Yina and I completed the wiring for the 6 flower pots connecting there: moisture sensors, LEDs, and servos. The light in front of the plant turns on to indicate that it needs watering. Just like in the video, when the moisture sensor reaches a certain level, the light turns off, and the plant's leaves gently shake to express gratitude. Since the fountain's angles, gesture ranges, and timing needed fine-tuning, we worked meticulously to make sure all functions flowed smoothly. We also conducted user testing to ensure intuitive interaction. Due to water-related challenges, even though we used waterproof fabric and glue, components still failed just before the exhibition. We replaced all the damaged parts in time. During the exhibition, I designed the poster, helped set up the space, and together with Juan, explained our project to the teaching team and visitors. The sound effect for the plants, "Thank you vibration after watering," was actually from The Legend of Zelda, a cute touch I really liked. Now, let's enjoy how the plant says thank you. When every plant is fully watered, they light up and celebrate together. Finally, I want to thank my team for their hard work, and thank our little plants too. Making such a cool project come to life was truly rewarding. Thanks for watching.